Here we're talking about arithmetic sequences and series. So first what we want to do is let's define what an arithmetic sequence is. So an arithmetic sequence, and we're going to say that this sequence is called A sub n. So what we saw in the previous video. Arithmetic sequence, call it A sub n. It could have been B sub n or whatever we wanted. But we're using A here, and it differs by a constant D. A constant D. This is called the common difference. And it differs by this constant D from term to term. Alright, so the best way to do this is jump in an example. Example 1. What is the common difference? And we're going to look at a couple examples here. So part A, let's say we have this sequence, 35, 25, 15, 5, -5, and so on. And what I want to know, what is the common difference from term to term? So the way you do that is you want to look here and see if there's a common difference as we go along each term. So here we're at 35, and then we're at 25, and then 15, and so on. So to get from 35 to 25, what do? We subtract 10. That works. Okay, let's make sure that matches the next couple terms. 25 to 15, we have to subtract another 10. And then 15 to 5, we have to subtract another 10. And then 5 to -5, we have to subtract 10 again. So we can see that our common difference here is what? Our common difference here is -10. And so a way that can help you kind of remember is you want to, so here we can say that D is -10. And I'll show you a helpful hint here in a minute of how to keep the positives and negatives straight if you're struggling with that. But the first thing I want, before I do that, I need to mention each of these individual these are terms. They're called something. So this first one, guess what it's called? It's called A1. Not very surprising. This is A2, A3, and so on. So an easy way to check your D is you can do D is equal to A2 minus A1, which is, let's go down. A2 is 25, I just wrote it right there, and then minus A1, which is 35. Simplifying that gives you -10. So D is -10 there. And that's how most of these will work when you're trying to solve these. Alright, try this one by yourself. 1, 4, 7, 10, and 13. And I realize you can do this one in your head pretty easy, but get used to showing your work and finding things, finding these things, because these are going to be pivotal in the next couple examples, just being able to at least identify these. So go ahead and pause the video and try. So I know A1 is 1. A1 is 1. So D will be A2 minus A1, which is 4 minus 1, which is 3. Alright, let's look at another. 1, 5, 10, 16, 23, and so on. If you want to pause the video to give it a try, go ahead. So you look at it, let's just first look at it from term to term and see what's going on. We know that this is our A1. To get from A1 to A2, we have to add 4. And then to get from A2 to A3, we add 5, add 6, and then add 7. So what we're looking for is a common difference. So common being the key word, it has to be the same thing from term to term. It has to be the same difference from term to term. So this would not be an arithmetic sequence. Not an arithmetic sequence. I'm going to abbreviate sequence there at the end. All right. Let's look at these examples and see what you think about this. All right. Example 2. No, first, actually, before we get into this example, I need to give you the formula or of what the nth term of an arithmetic sequence is. So the nth term, and this is important to know, the nth term of an arithmetic, I don't want to abbreviate here, arithmetic sequence is, so the nth term of arithmetic sequence is, and here comes the formula, an equals a1 plus n minus 1 times d. Alright, so to be able to determine the nth term of a sequence, you need to know a1 and d, which are the things we just figured out. So example 2. Let's say, write the formula for the nth term of the sequence. Alright, and here's part A. Let's do the same one that we worked in example 1. Let's do 35, 25, 15, 5, and negative 5. And that just keeps going. So what this nth term of the arithmetic sequence does, it says if I want to know what the second term is of this sequence, then I just plug in 2 into here and out should pop a 25. If I want to know the fifth term of this sequence, when I plug it in here, I should get a negative 5. If I want to know the 1/1,000,000th term, well, instead of doing negative 10 to each term a million times, I have this formula now that will pop out that number for me. But first we have to do some work. First when you do these, it's always a great idea to write your formula first. an is equal to a1 plus n minus 1 times d. And then we need to determine what things that we need to use, or what things we have. So do we have a1? Yes, it's this term here. That is a1. And then we know d, it's a2 minus a1, which is negative 10. And that's also the same example we did earlier. Alright, so now let's plug in and see what it looks like. an is equal to a1, which is 35, plus n minus 1 times d, which d is negative 10. And it's time to simplify, do some algebra here. an is equal to 35 plus, and now what we have to do, it's probably a little backwards from what you're used to seeing, but it still works the same way. You take negative 10 and you multiply it in to both of these terms here, n and minus 1. So negative 10 times n is negative 10, and then negative 10 times negative 1 is positive 10, and I messed up. I forgot an n. So you have to be careful. an is equal to 35 plus negative 10n, so negative 10n. And it's okay that I have a plus and a minus here. We'll work that out in a second. Don't try to do too many steps at once like I did. And then negative 10 times negative 1 is a positive 10. Alright, so here you're essentially just multiplying these two, a positive and a negative, together. When you have a negative times a positive, that's a negative. So AN is equal to 35 minus 10N plus 10. All right, some of you could have just jumped to that step, and that's okay. That will be perfectly fine when you're showing your work on the test. And then we want to combine like terms, so 35 and 10. So AN is equal to 45 minus 10N. And what you'll notice is, if I decide that I want to find, let's say, A3, that means I plug 3 in here everywhere there's an N. So 45 minus 10N times 3, which is equal to 45 minus 30, which is 15. And this 15, I found A3, 15, and 15. So that's what I was looking for. So now if I want to find A of 1,000, all I have to do is plug it into my formula that we created.